We got 2 more minutes.
Okay, welcome from the IIBA Tampa Bay, Florida chapter study group. This is November 2nd of 2023. This is our 98th study group, our 98th class. Today we're going to be talking about the techniques of functional decomposition, state modeling, and decision modeling. Looks like we're going to do it this way. Okay. The mission here is to bridge the gap between industry leaders and business analysts by building partnerships with professionals, educators, and employers so that we may empower, instruct, and engage the BA community. You'll notice that we are the Tampa Bay, Florida chapter, but we have a worldwide audience and we welcome everyone. We have a variety of ways for you to reach us. This is our Thursday night study group between 7 and 8 p.m. Eastern. You can reach our past meeting recordings and get an index of all those recordings and topics at the addresses that will be dropped into the chat. We also have an IIBA site, Meetup, Zoom, Facebook, and LinkedIn sites. You have a variety of ways to reach us. Reach out to us. Watermark Learning has provided a discount code, TampaBayIIBA which gives us 20% off of any of their products, not only business analysis related, but project management and a couple of other topics. They have flashcards, practice study questions, practice test questions, study groups, and a few other things that are of interest and useful that we found. We are a volunteer-led organization. Cliff is our president, also our marketing genius. Yulia is our vice president of finance and awesome. Kayla and Priscilla are board members at large. My name is Thea Soehren. I'm the vice president of career and professional development. It is my job to help you learn what you need to learn and answer the questions you want answered. So reach out to me through LinkedIn and I'm happy to help you. Whether you are a member of another organization or not, we want you to be a new board member for us. A new board member means we want you to attend our study groups. We want you to perhaps consider presenting 1 or 2 topics occasionally. We want you to see what other things we can benefit from you and you can benefit from us. It looks good on your resume too. Reach out to Cliff or I on LinkedIn and we'll talk about it. We are graciously appreciative of the study group advisors. We've got Bob Churchill. You'll see him on the on the left of your list. And we have Yulia, who was a student, and she is on the right there. They are CBAPs, and because they are attending, that means that you get 1 hour of study group credit for attending this class. We want to celebrate our wins. Where is my cursor? My cursor's stuck. There it is. We want to celebrate our wins. We have a variety of people that have reached out to say that this study group has been instrumental in them receiving their certifications. It's very appreciated whenever they do that, because as you know, we don't get anything from volunteering for this. We're not charging money for it. We don't get anything as a chapter. We're doing this to lift up our community, and you tell us we're doing a good job. So please continue to let us know. Roshni is our latest CBAP. She has earned her CBAP, and she has also inquired about becoming a board member. So not only has Yulia been a board member, but Roshni is considering it. We really appreciate that. Thank you so much. Recently, the IIBA is celebrating their 20 years of existence, has announced that they will give 20% off of all exams. This is the year-end promo. If you go to the IIBA website, you can get this. It requires you to be an IIBA member, which means that you're in good standing, you've paid your dues. It also means that you're going to write your test between now and the end of December, which means not write the test, but take the test for those of you in the United States. Taking the test means you actually take the test before the end of December. So this gives you 20% off. It's worth it for the money. And the rebate applies to exam fees and exam rewrite fees only for all 7 of the tests that are available. Okay, now we're going to jump over to Bob. He's going to talk about functional decomposition, and then I'll talk about state modeling, and then Bob will talk about decision modeling. And I will end sharing, so Bob, you can take it over. There you go.
Okay, we have 8 more techniques to cover in the 3 weeks we have remaining before we go on holiday break. So without further ado, let's try to bang through them relatively quickly. English is such a great language. I wish I could speak it. So, functional composition is basically the act of breaking large problems or concepts down into little ones. So, my first engineering job was as a process engineer in the paper industry. So, what we did was design systems that took large piles of wood in the form of logs that were turned into chips, run through a bunch of equipment of various kinds, and turned into very large rolls of generally newsprint. And these machines would be up to 50 feet wide and produce paper at 50 miles an hour onto these giant spools. So obviously newsprint is less of a uh commodity than it is now. Many of the plants I worked at and did analysis for are no longer operating. Some of them aren't even there. But when I was in Quebec City, which is where these 2 pictures were taken, that plant is still there and still running. So here are the is one of many drawings I did to show how the process works in these kinds of plans. And here are some of the kinds of machines that were used in the plants. So if you think about an entire process, you want to break it down into little pieces, and you need to understand the form and function and operations of those little pieces. By the way, this is a screw dewatering press, and we had one older engineer. So I was there in my say mid-20s, and this guy was 60, and he had an armload of patents. And this is a metal cover that went over a screw dewatering press. So you'd feed pulp into here, and it would squeeze the water out, and this cover was meant to keep water from squirting all over the place. And I saw a plant in one place where this cover was long gone, and they'd hung up 2 shower curtains and these flimsy little rods, and I took a picture for him and gave it to him. So anyway, there's a lot of interesting and fun things you see out there. The main thing that did most of the work was what we call thermomechanical pulp refiners that took the chips under pressure and ground them between these giant rotating plates with teeth that stripped all the fibers off the chips and turned it into pulp. So the way it worked was there was 2 outer rings with plates on them. Here, the dark things, and a giant rotating disc. So this was a motor up to 22,000 horsepower and smaller. and it would feed the chips along the shafts on there would be a kind of a feed screw along the shaft that would press the pulp in to where it was fed out between these blades, and then it would go out. The machine would add a huge amount of energy, generate steam, shred all the paper, and then go through many screens and cleaners and other things, and then to the paper machine. And as a process engineer, basically a business analyst, for physical type of machines instead of business processes, you know, I did the analysis for understanding what happened in the whole system. Another way, if you want to look at common objects, you can look at, and I think what I will do is make this larger. Yeah. Come on, get bigger. All right. If you look at the gas pump, a really common object, there are thousands of components and other things you might want to know about. Think about how it exists in a process that a user uses. So here I've called out about 20 different things. But all of these subcomponents, they're all part of different processes used by the user, used by advertisers, by maintainers, things designers have to know about, and so on. So one thing we want to do as we break problems down and work through a life cycle of solving a problem is we want to do requirements traceability. So we basically, and all of you who have heard my spiel about the way I think about breaking problems down across 6 phases, the intended use is defining the problem, conceptual model, at least for existing systems, is finding out the as is state, so finding out what's your starting point, and then requirements, or here's what we're going to do and automate and or change. The design is how we do that, then we implement our solution and test it and do acceptance. And if we inject non-functional requirements, there are other requirements that the solution has to have that aren't necessarily about what the system does. They're more about what the system is. And we can also break down things over time as we understand them in more detail. For example, we can break epics into features. We can break those down into tasks. Then we can run one or more tests on all those. And when we pass those, we get acceptance. Also, as we break things down throughout the life of the process, we also want to break things logically down in a hierarchy of all the components that make up a system. So, for example, if we have an aircraft, you know, we've got the vehicle, and we've got some program management, in training and data and a lot of other things for a project. That's just one way to think about breaking things down. We could break it down by avionics systems, engine, wing, fuselage, tail, landing gear, cargo and passenger type facilities, and so on. So there are many ways to break things down into logical hierarchies. And if you want to mirror those two together, you can break it down across phases and also kind of merging hierarchical breakdown into the thing kind of at right angles. You can also think of it this way instead of the way I've shown it. I linked to the slides for a presentation I gave that includes this that talks about all the ways to do things in different orders and mirror these two things together. Another way to think about breaking systems down or concepts down is to think of things like an equation. So here are a couple of examples. We've got the first law of thermodynamics, which is the net heat change, is the change in internal energy. And we have a term here for velocity, the force of gravity, and work done on the system. So if you remember the refiners I talked about, they add a lot of mechanical work into the system, and that turns into heat, which is what turns all the water and pump into steam. So there's a lot going on here. And if you think about things in terms of equations, when it's appropriate, then you will be able to think about how big a component is within a larger whole, and what happens when you modify all the parameters. Another example, and this is not an actual equation, it's just kind of a heuristic to talk about how prices change as the demand and supply of goods changes, and the demand or supply and demand of money in the wider economy changes. So it's kind of a way when you print more money, prices tend to go up. When you have greater demand for goods, the price tends to go up. When the demand for money goes up, the prices tend to go down. And when the supply of goods goes up, the prices tend to go down. So that's another way to think about the effect of inputs on outputs. And here's a breakdown of a bunch of pieces of data that fed into the total need for staffing at all kinds of port facilities in the United States. We did this calculation for 400 different locations, and this enumerates all the factors that went into doing that calculation. So you can see that there's a potentially lot of data that go into making decisions and justifying needs for resources and what have you. And we break it all down into detail. If you look at the way items move through a system, whether they're documents or requests or people or physical objects, they can get routed from one process to another. and they will go to certain places or along certain paths a certain percentage of the time. So that's another way to break things down in a different point of view. You can look at entire processes as flowcharts where you break down all the things that happen. You can break down each sub process. So every box in here, it can basically be thought of this way. You can look at every process in terms of all its inputs, what the inputs are, where they came from, the sources. Then you can look at what the outputs are and who they go to and where they go, right? So you have to think about all these things in detail. And then here's another way to think about processes. This is all the activities and all the different things that come into one process box in a project I did back in the early 90s for a disability insurance underwriting analysis that we built a system for. And we broke down how many of these things we get, how long they take to process, and so on. And there's not every entry in this particular thing, but if you looked at the entire process for that business operation in all these boxes, then all the inputs and all the activities would have been represented in one of these process boxes in the larger system. So again, we're breaking stuff down. Here's another type of system I worked on. It's a steel mill, and we used to build reheat furnaces, and they had control systems in 3 levels. So steel would come into a scrap yard, and it would get poured into a melting type furnace. Then that would go into a ladle, that would go into a caster. It would make steel slabs that would be reheated, then rolled into coils, thus it be mended up and shipped. Every single one of these giant pieces of equipment, the caster and the rolling mill were multi-$100 million machines. Our furnace was 800 feet long. They all had 3 levels of control systems. All these things had to talk to each other. They had to have multiple pieces of information. They were all very complex, and we had to negotiate all the communications and interfaces between them. In the plant itself had a level 3 system that followed physical items through the plant, and that interface with business systems for personnel, sales, ordering, accounting, all that kind of stuff, in shipping. And they were attached to external systems which provided input and generated output data. So as you see, there's a ton of stuff that analysts can get involved in. here is all the pieces that were involved in a line of controllers for HVAC equipment, and different elements of this would be included on controllers of various complexity. So a simple controller might only have a few of these boxes or different levels, but a more complex area controller that talks to many systems at once might have a bunch of these boxes. And thinking about him in this way, and the parts that were consistent across multiple devices, is a way to think about when you do things the same and you're consistent, and when you want to do things different or custom. Another way to break problems down is using a fishbone diagram. It's a form of mind map. So you're trying to do a root cause analysis to see what might be broken. And I think we had these 6 steps, right? So it was measurement, materials, man. We don't say man anymore. We say people. Mother Earth, we don't say that. We say environment, methods, and machines. And you break stuff down. It's an organized way of making you look at a problem from as many possible points of view as possible to break stuff down. And I always love showing this picture because it illustrates that if you look at problems from different angles, you see very different things potentially. So that is what's going on. The BABOK goes into detail about some of the ways to do this. So it talks about what you're trying to accomplish and why you do these things, subjects that you can break down, and how far you break things down, and also how you actually depict what you break down. There are as many ways to do that as there are problems, but there is no problem that cannot be broken down. It's up to your knowledge, experience, and creativity to do what is appropriate for your problem in your analysis. And the key thing is to get help from all the appropriate people who know how to think about all the different parts of it. And that's all I have to say.
Okay. Do we have any questions? Has anyone ever used functional decomposition?
All the time.
All the time. Thank you, Jim. I'm like, I can't be the only one. Okay. Because we're covering 3 different topics today, I'm going to go ahead and take the screen and move forward. We covered functional decomposition. Now we're going to do state modeling. Once again, if you haven't been to rpchurchill.com to see the Tampa Bay study group, we have a list of every recording that we have been able to keep there, and Bob was kind enough to organize it for us. And if you go down here to the bottom of that same list, you can see the techniques that we've covered. Some of them we've covered 2 different times. Some of them we haven't covered yet. We do have a volunteer to cover user stories next week. So we have that underway. Okay, so talking about in the BABOK, it's number 44 in techniques. This is our state modeling. And I want you to know what the BABOK says, because the questions that you'll see on the certification tests are going to be, what does the BABOK say about it? So I want to go through the BABOK with you real quick. State modeling is used to describe and analyze the different possible states of an entity within a system, and how that entity changes from one state to another, and what can happen to the entity when it's in each state. So the description: an entity is an object or concept within a system. An entity may be used in several processes. The life cycle of each entity has a beginning and end. In a state model, sometimes called a state transitional model, or I think it's a state machine model, a state is a formal representation of a status. It is used when necessary to have a precise, consistent understanding of an entity that has complex behavior and complex rules about that behavior. I want you to know an entity state diagram, or this diagram, can be used for something simple. And I'll show you a simple way to use it in just a minute. A state model describes a set of possible states for an entity, the sequence of states an entity can be in, how an entity changes from one state to another, the events and conditions that can cause an entity to change states, and the actions that can or must be performed by the entity in each state as it moves through its life cycle. While a process model could show all the entities that are used or affected by that process, a state model shows the complementary view, what happens to one entity across all the processes that affect it or use it. There are elements to this. You've got your state, and so it talks about the specific ways that that entity can live. The state transaction, what causes it to change from one state to another, and what triggers it, what the differences are in each one of those states. And then you got your diagram, and here's a state transition diagram. Here's your initial state. It transitions to state 1. And this doesn't make any sense because you don't have names, but I'll show you something better in a minute. And then something happens. This is some kind of transition. You got a trigger transition. It triggers to state 2. State 3, it can be here and turn into state 1. It can turn into state 2, but from state 3, it's final state. And then there's a state table. It's a 2-dimensional matrix that basically says in state 1, it has this criteria, and it can impact or impacts these things. And I'll show you something like that in just a minute. I want to talk about some ways that you can find out more about state diagrams. This is a really awesome website, a visual paradigm. I can't say that word. What is a state paradigm? Thank you. This has a whole bunch of really abstract state diagrams. It talks about when to use state diagrams, which one, my favorite, is business processes. And then this, you may recognize, this is a user story diagram or a use case diagram. We use those all the time, but this is a great way to say, okay, this is where we're going to start from. And you'll notice it uses notations here. I'll talk about those in just a minute. Elements of a state diagram. You got your state, your transitions, your inputs, outputs, initial state, and final state. Not all processes are going to have a final state. And I'll show you that in just a second. Let me switch to a different screen. So for state diagrams, this is my super simple state diagram. You got a door. The door is closed, the door is open. You also have accompanying conditions. Here's the transition. The door is opened by a person or when. It goes to door open. The door is closed by a person or when. It goes to closed. And then you're going to have resulting possible actions. And we'll go to something a little more complicated for that. So we're talking about state modeling for a retail customer in a store. We don't have any information about them. They come in, they pay cash, they leave. We don't know. Retail customer online. They provide an email. So then our system is going to send them monthly emails. We know that we have this kind of relationship with them. So there's also 2 other states. They're retail customer, store, and online. They are a frequent buyer program member. In this case, they're going to receive weekly emails. They can use a weekly discount on specific products. We're going to send them a birthday card yearly, and there's a birthday discount available. Or They can be a Keepsake Ornament Club member, and they also receive emails beginning in August. They receive a monthly discount on Keepsake Ornament products, and they also have birthday cards sent yearly and birthday discounts available. So those are our different states. Here's the diagram. Each customers can begin in any state. They don't have to go from one to another, but this is how they go from one to another. Store a customer, retail store, the retail customer for a store makes a purchase online. They are now in this state. Now we have their email. Retail customer store signs up to be a Keepsake Ornament Club member. And so they're transitioning from one state to another. But let's look at this. Now that we know how they can transition, let's consider, what if they are a retail customer and store online and they're a Keepsake Ornament Club member? In this case, we would have to go in and say, which one do they get? Do they get this birthday card that's specific for this thing? Or do they get this birthday card specific for this thing? We're going to have to change our systems. So in this case, we have to be cognizant of, how do we want to market to this particular combination? What do we have to do with our systems to change it? As well as how do we market to these people? So that's a difference in states. Now let's talk about UML. UML is not a programming language. UML is a graphical representation tool. It's got some symbols that are really important that you understand just the basics of them. It's used to portray the behavior and structure and relationships between entities. You can get super deep in this. As a BA, typically you don't need to, unless this is just your jam. Yes, thank you. UML, 24 hours, he's got a book. There's lots of information online about UML, but here's a few things I just want to show you really quickly. It's not going to load my graphs. Reload. You'll look at this and go, it's got a hierarchy, and that's all that it needs for UML. But you'll notice that UML is great. UML is used for a lot of different kinds of diagrams. Let's go down. Here's the object-oriented concepts in UML. You'll notice it's got similar things, class and objects that we talked about earlier. We also has inheritance and abstraction. But if you look at the diagram list, here's class diagram, composite structure, object, component, deployment, package. And then here's state, activity. I mean, guys, you can use UML for a lot of different things, and it gives you basically a template to use. Things that you need to know about UML. Well, this is loading. Yulia, didn't you see UML symbols in the CBAP test?
Yeah, they were given diagrams, yeah, to read. So I was learning how to read.
So I showed, So I showed you on that quick thing of a door open and a door closed. Let's talk about, let's make it a little bit more difficult. What if it's a door in a smart home that has programming behind it? So here's a time greater than or equal to 5 seconds between open and closing. Here's the states. And then let's talk about, make it a little bit more difficult. So the smart home, you've got commands being sent. You've got situations that have to go on, not in a locked position. All of these are symbols for UML. So if you want to get deeper into it, you can. UML has a lot of cheat sheets online. There are, let me make this bigger. Here's how the shape for a package, shape for an interface, but here's my favorite. Whenever you go to UML cheat sheets, you'll see things like this. Make it larger. Here's a state diagram. This is final state. This is initial state. You don't have to label them because the symbols tell you what they mean. So you've got your transitions, you've got your actions, you've got your events. This is the format that you would write your state diagram in, as well as a couple of other diagrams that you're familiar with. Sequence diagram, actigram. You don't have to use UML for these. You can make it as easy as you want to, as long as your audience understands it. If your audience is a bunch of engineers, they're probably going to want UML. If your audience is, the business people, don't use UML. You'll confuse them. Any questions?
Yeah, so
Any comment?
UML involves a lot of separate techniques. Some of them are techniques that are in the BABOK of the 50, right? A handful of those, 2 or 3, are discussed in UML as part of it. The BABOK mentions USL and acknowledges that it exists. It's a nice thing to know. What's more important to know is that the method you use to communicate with your customers and coworkers and engineers and users and so on is whatever works. So don't necessarily feel bound by that. The BABOK mentions UML. It doesn't go into it in detail. And the last thing I'll say is that items don't necessarily have a beginning and an end. State something that comes into your system and then leaves will have a beginning and an end state, but something that stays in your system, it won't have an end state. It'll continuously cycle over time. So there are a lot of ways to think about these things.
That's right. The place that I've used state diagrams the most is whenever I'm talking about risk analysis. And basically it's, if this situation happens, if it's this criteria in this state diagram, then we know we have to do A, B, and C. And that's my favorite place to use state diagrams, because it turns it into a picture. It's not just on a list somewhere. Any questions on state diagrams? Okay, last topic. I'll turn it over to you, Bob.
All right, let's talk about decision modeling. Can you see this?
Yes, we can.
All right. So basically, decisions are driven by data and rules in combination, right? And there are a lot of kinds of decisions. So a really simple one is, we have this table based on the loan amount and the age of somebody, determines the kind of thing, kind of loan they can get. For example, you can express that as a table. You can express it as a flow chart where you go through, and you can express it as code. So this is code in a C-like language, might be JavaScript, might be PHP or whatever. A lot of languages look very similar, but as you see, over time, we've been using more and more data in more and more complex ways. So the first thing we want to think about is the quality of the data that we're using. And then we want to think about what we can analyze in terms of the data. Then we want to think about looking at all the data to do forecasts and figure out what might happen in the future. We want to be able to identify patterns and sometimes take proactive action to head off problems before they occur. And then we also want to use more and more complex analysis and less structured data. So over time, we're optimizing to make systems work better and more efficiently. And we're also trying to glean meaning out of unstructured data. So we're doing more and more complex things. And the BABOK doesn't really go into a lot of detail about really high level uses of data and making decisions. It mostly says you have knowledge, which is the context in which you apply data. The information is the data itself. So these age thresholds and these loan thresholds might be information, and knowledge is the way they're combined, right? It's the kinds of decisions you make, and the decision is the actual result of the calculations that you do. So we have the decision trees. I think there's another technique that's very similar. It's called decision analysis. It has a few other examples of ways to make decisions. So based on the kind of input you get, whether it's a document or a customer, you'll handle it differently. You'll have things processed based on characteristics that do not change over time, but also sometimes as things sit in your system and they age over time or change in other ways, then those will trigger different kinds of actions. So we talked about that in another technique. And the more you know about programming and the way to express different concepts and decisions and thresholds, the more comfortable you'll be with handling a bunch of these things. So data fits into every part of the process. All these boxes take in data. They output data of various kinds. They're operating data that talk about how the system is running. So you want to think about all the forms of data and the kinds of decisions you can make based on that data. And that's really all the BABOK says about decision modeling.
Okay. Any questions?
And we got through 3. We don't usually do that. We have 2 more weeks. We have 5 more techniques. And we'll get through it all for sure.
Yes, we will. Okay, we have a few minutes left. Let's talk about what we're going to do in the next 2 weeks, and then what we plan on, what we want to do on the week we return in January. So I want to share something real quick. One of the things that I think is best about our study group is we have discussions. And I found this this diagram, and I want to give credit to this guy. He talks about public speaking and using your voice as an instrument. But this particular gentleman posted this, and I think it's really valuable. whenever you listen to a topic, you retain 5%. When you read it, you retain 10. When you listen and read, you get 20%. Demonstrate is 30%. Discuss is 50%. Our discussions that we have here in this study group have been cited by many of those that have said that the study group was beneficial to them, because we hear people's perspectives. We have people say, oh, but you missed that word, or that word is important because, or we can't use this answer because the BABOK says this other thing. The discussion is what makes us valuable. And we retain 50% of what we discuss. So those of you who are participating in the discussion, who are demonstrating the techniques, who are listening and reading, those of y'all are going to get a lot more than folks who are just passively listening. So I'd like to encourage you to lean in and join the discussion, and let's see what we can get done together. So we have a couple more techniques that are still outstanding. We've got balance. Can you see my screen?
Yeah.
Yes.
Good. Okay. I don't see the line around it. I was just suddenly worried that you couldn't. Okay. We haven't done balanced scorecard or benchmarking and market analysis. Is that correct?
Yep.
Okay. We did data modeling today. We did decision modeling today. We did functional decomposition. I'm sorry, we did state modeling. Which one have we not done? Data
We have not done user stories, which I think Ashish has volunteered to do. Balance scorecard, we have to do that in benchmarking and market analysis, a business model canvas, and data modeling we have not done yet.
Okay, so those are the ones outstanding. Ashish is going to do user stories next week. If we have any volunteers to do any of these others next week or the week after, it's your last chance this year to present one. And
I will update this list this evening or tomorrow sometime, so you know what's still available.
All right. So Ashish, thank you for volunteering to do user stories for next week. We want to do either one or two more techniques next week. We have 5 to go. We only have 2 classes to go before the end of the year. We are going to hit 100 study groups together, guys. Look at us. If there is something that you're interested in for us to do in January, let us know. We're thinking about doing a professional series, as well as talking about the current situation of for Rushing, that she passed the CBAP. What was her experience? We realize that the CBAP may change periodically throughout this cycle. And if it's any different now than it was 3 months ago or 6 months ago or 9 months ago, those of you who are getting ready to take it are going to be interested to find out what the differences are. So we also have a couple of people that committed to in the next, let's see, 12, 16, 18 months to take your CBAPs. That means that in the next 6 months, you got to get your application in and get it completed by the 6 months from now. We're coming, time is being eaten up. So if you need assistance, if you have specific things you're interested in, if we want to do specific chapters, let's talk about that, and we'll make the plan for January, February, and March. If you have specific people that you're interested in presenting to us, if you want to suggest somebody, bring those to me. Again, the professional series has always been well received, and it always helps us to find out who are the professionals that we work with as BAs, and what do they need from us, and what can we provide to them. That helps us to utilize their skills better. It helps them to utilize ours better. And of course, it helps everyone to understand what business analysts do. Does anyone have any comments or questions right now? Okay. All right. We're doing fine. Okay. I want to give a big shout out to Bob, who has been consistent in attending and presenting and preparing. I want to give a big shout out to Cliff, who does marketing like nobody I've ever seen. So effective. I really, really appreciate it. And I want to shout out to Yulia, who attends whenever she's able to, but she's also taken on the Vice President of Finance position, which was something that the rest of us did not have the ability to do at that time, and we needed to do it. So you guys, you make us rock. And those of you who attend, especially those of you who have attended consistently or maybe consistently and then had to leave for a while and came back, it's very gratifying to see your faces and see your names. It's almost like we're friends. We don't get to talk as much as I'd like to, though. But we have some time. If anyone wants to reach out to me through LinkedIn, I'm happy to provide assistance. I'm happy to just get to know you. Spending 15 or 30 minutes together just to share what we're doing and what our challenges are and what we want to work on next, where we want to grow to. It's never a bad thing. So if you want to reach out to any of us through LinkedIn, go ahead and do that. You're not going to be turned away. Okay. I don't know that we have anything else. Does anyone have any questions, concerns, comments, suggestions?
No, very efficient tonight.
Yes, we are very efficient. We started about 2 minutes early. We're going to end about 7 minutes early, so it's not so bad. Okay, folks, we will see you next week. I hope everyone stays safe. I'll talk to you later. Bye.
All right. See you guys later.
Bye bye.